Alright, so suppose you've got a radical expression like this, the square root of 36 over 7, and, being a person of style, you want to get it in its simplest form. You want to simplify it, clean it up, see what you can do to make it nicer. So you say, well, you know that the square root of a quotient is equivalent to taking the quotient of the respective square roots. Might not have said that correctly. It's this. This is equivalent to this. And the square root of 36 is 6, because 6 times 6 is 36. Square root of 7, you could turn that into a strange number. Let's see what that would be. Sorry. Square root of 7. 2 point something, and the numbers go on probably forever without any discernible pattern. So you could just leave that as square root of 7. Well, it's considered bad taste, basically, to leave a radical expression in the denominator of a rational expression of a expression like this with a numerator and a denominator. So what you can do is you can just multiply this by a fancy version of 1. So it's just like when you're finding common denominators of fractions. You say, well, I want to turn, the common denominator here is going to be 15. So I have to turn this 5 into a 15, so I multiply that by 3. And then because I do that to the bottom, I need to do that to the top too, so that the fraction keeps its value. It's just expressed with a different denominator, right? Well, this is equivalent. What you can do is you can actually multiply this rational expression by square root of 7 over square root of 7, because what that allows you to do. So this is 1. Can we agree on that? Anything divided by itself is 1. So square root of 7 divided by square root of 7 is 1. But what happens is you do square root of 7 times the square root of 7, which is the square root of 7 squared, right? Square root of 7 times square root of 7, square root of 7 squared. Well, that's just equal to 7. If you square something that you square root, you're left with that thing. So that's 7. So now we no longer have an irrational number in the denominator, and we no longer have this radical expression. So and then the top, just do 6 square root of 7. So we've now rationalized the denominator. A lot of these roots, I believe square root of 7 is one of them. Definitely square root of 2 is one of them. If you take square root of 2, their decimals, this is just rounding. The decimals actually go on forever, and there's no repeating pattern there. So what that means is you can't express those roots as a fraction. You can't say it's something like 2 over 3 or anything like that. So they're called irrational numbers, numbers that can't be expressed as ratios or fractions. So so a lot of times, since the radicals are actually irrational numbers, when you get rid of radicals in the denominator, it's called rationalizing the denominator. So we've just rationalized the denominator here, and then this would be the simplest form, or the nicest form, the most stylish form of this. So that is what we've done. Now the question is, what about if you have something crazy like this? So you might think, I don't know, let's just multiply the denominator by, let's pick one of these, square root of 2. I'll show you what happens when you do that. Let's say we're going to multiply this rational expression by this, or by square root of 2 over square root of 2 to try to rationalize the denominator. Well, square root of 2 times 2 square root of 2 is 2 times 2, which is 4. So that's nice. But square root of 2 minus 3 square root of 3 is actually 3 square root of 6. And that's what you're left with when you distribute this square root of 2. So you haven't rationalized the denominator at all. I mean, there's still this radical expression in there. So that's kind of a bummer. So what do? Well, what you do is you figure out what the conjugate of this binomial expression is, and then multiply by that. So the conjugate of a binomial is simply just flip the sign between the two terms. So here I've got 2 square root of 2 minus 3 square root of 3. So what I'm going to do is multiply by 2 square root of 2 plus 3 square root of 3. I'm going to do that. So I can't just multiply this fraction by whatever, because that changes its value. But if I multiply it by a very crazy looking version of the number 1, some number divided by itself, it'll retain its value. It'll just look different. The denominator will be rationalized. So here's what happens when you do that. So we need to multiply this whole binomial by this whole binomial, and what we'll do is we'll FOIL it. I'm going to multiply this by this, then this by this, and then I'm going to multiply this by this, and this by this. Okay, so let's do that. So 2, so we've got, let's just write all this work out. 2 square root of 2 times 2 square root of 2 plus 2 square root of 2 times 3 square root of 3 plus negative 3 square root of 3 times 2 square root of negative, or square root of 2, and then we've got plus negative square root of 3 times 3 square root of 3. So let's see what happens when we do that. The key here is this. This and this term cancel out. These are just in a different order. 2 square root of 2 times 3 square root of 3, and then we've got negative 3 square root of 3 times 2 square root of 2. So these are the same thing, except this one's negative. So these are going to cancel out. This plus this is going to equal 0. And that's the key here. So what happens is this. So we've got 2 times 2 is 4. Square root of 2 times the square root of 2 is the square root of 2 squared, which is 2. So this is 4 times 2, which is just 8. And then we've got negative 3 times 3 is negative 9. And we've got square root of 3 times the square root of 3 is 3. So that's altogether negative 27. So 8 minus 27 is whatever that is, negative 19. Yeah. So the whole denominator here just became negative 19. No radicals. They're all gone. Alright, so that's the power of multiplying by the conjugate. You just flip the sign, and what that does is it allows those two middle terms, when you FOIL all this out, to cancel out. And that's the key. So then, of course, we have to multiply the top by this same expression. So 2 square root of 2 times square root of 3 is 2 square root of 6 plus, and then square root of 3 times 3 square root of 3. Square root of 3 times square root of 3 is just 3. 3 times 3 is 9. So that would be this expression rationalized. No more radical in the denominator.